Hello grade 12s, welcome to my channel. Let us have a look at some questions that may need your attention so that in the final exams, guys, you are comfortable doing certain potentially difficult questions rather effortlessly or with no fear at all. So there are some questions that can truly make your life in the exam a little uncomfortable. If you look at the May June 2024 exam, look at the trigonometric identity there that needed to be proved. It was not the standard approach. So technically it was more of a reversal type of thing. So it can be quite complicated. Sometimes the easier approach is not always the approach that can work. So if we look at this, we want to essentially prove this trigonometric identity. Now we use the three-step approach, which guys you already know. I don't need to reintroduce it to you. But now this is the time to showcase that if one understands that, and it's sort of a second nature type of thing to use it, you can see how easy it makes your life, and in fact how quick you get to the answer without struggling. Alright, so anyway guys, there's plenty of videos in the channel where you can learn about this approach I talked about. And you have plenty of past exam question papers that I have done. Some single questions, some questions focused on a particular topic, some being comprehensive, others just individual questions, just like this video. So I would like us to explore what can happen here. Now, of course, guys, whenever we assess this situation, we will see that, okay, we've got a very complex angle here. It's a triple angle for that matter, or a compound angle at least. But these are single angles. So we often choose the complex side. We can see that the left-hand side is a bit complex. Okay, so that's the standard approach. We choose the complex side first. This is equal to, we can break this up into sine 2x plus x, just to create a compound angle, as this has spelled out a compound angle identity. So we get sine 2x cos x, the sign remains. We get cos 2x times sine x, okay? That's the sine compound angle expansion. Now sine 2x we don't want, so we use our identities. It becomes sine x. But now cos x times cos x becomes cos squared x. Plus, this one, we want this in terms of sine because on our expression we've got sines. So this is going to be 1 minus 2 sine squared x times sine x. Right. We continue. We get here 2 sine x into, we don't want a cos, so using our double angle identity, this is what we end up with. Plus we fold this out, we get, we get sine x minus 2 sine cubed x, okay? Right. So we keep going, we fold this out, we get 2 sine x minus 2 sine cubed x plus sine x minus 2 sine cubed x. Right, so we've got like terms now, so we know that this dude and that dude add nicely. As you can see, this is just spelling out our, three-step approach. So 2 of the same plus 1, we get 3. sine x minus, again we've got this and that, so 2 of the same plus another 2 of the same, we get 4 sine cubed x. Isn't it equal to the right hand side? This is equal to the right hand side, and our identity has been proven. So with the standard approach, no issues. We just go about business nicely. Of course, how would you score marks here? Technically, using any identity expansion, that's a mark, okay? First thing. All right. And of course, here when we used identities, we get a mark for this. Even here we used identities, we get a mark, okay? So that's a 3-mark thing. And of course, using identities, again here, the square identity, we get our 4th mark. Of course, dealing with like terms and all that, BODMAS, whatever, that could be an extra mark. Although this answer has been given, but it sounds logical because we are following a pattern of solving here. So at the minimum, should we say 4 marks? So that's what can be scored. It's actually 5. This is essentially a nice 5 marks. Of course, it could easily just stick with 4 marks, but because of the operations that we had to do, at least 5 marks is justified. All right. So this is nice, easy. This is how a student should do business in this kind of a question. But then what happens when we decide to be charismatic, or let's just assume we don't see it? How about we take the left-hand side? Sorry, how about we take the right-hand side instead? And we push it back into the left-hand side. So this is 3 sine x minus 4 sine cubed x. Alright, so what do we do with this? Of course, guys, following our 3-step approach, we know that we can actually take sine x out as a highest common factor, and then we end up with 3 minus 4 sine squared x this time. Okay, so we factorized by taking out the highest common factor. But now we look stuck, right? We look stuck at this stage. So what is available to us, folks? Well, one thing I can tell you is that sometimes choosing very challenging approaches can really lead you into some serious problems. But I can assure you that a skilled approach will always yield good results. Let me show you how this thing can work. Okay, so we can say, okay, this is the same as sine x into, we can see that 3 is basically 2 plus 1, isn't it? Minus, this one is the same as 2 times 2 sine squared x. Right. So we know this is the case. I mean, we can put this together and say, okay, this is the stuff that is happening. Maybe we can say that is also the stuff that's cooking. So it's a very skilled and logical way. So again, logic kicks in. Of course, guys, this one can be very overwhelming. Sometimes you get to an answer, sometimes you don't. In fact, it can involve multiple trials. But I can promise you one thing. If you stick with the 3-step approach, you will almost always come to an answer at some point. Okay, let's just keep it nice and clean. So what then? Now we can see that there's a 1. If we fall, what is inside the bracket? We can leave the sine x outside. But now we can take the 2, right, and bring in the minus 2 times 2 sine squared x, right? and then we leave the 1 alone because the 1 is not going to help us. Right, let's just leave this square bracket. Of course, we continue sine x into what we can see. There's a highest common factor within these two, which is a2. So we take that 2 out, we get 1 minus 2 sine squared x plus 1. Okay, so we're kicking it nicely. And we can see that, okay, this is sine x into, this is as good as 2 into, but now that's an identity. 1 minus 2 sine squared x is basically cos 2x plus 1. All right, we're moving on nicely. So we've got sine x outside into, we can break the big bracket now. What's happening here? We've got 2 cos 2x plus, now we think about that 1. This 1 of ours is an identity on its own. So what can we do here? So since we can see that, okay, we ended up with a double angle here, so we probably want something that would look like it. Let's go back to some double angle identities. Take cos 2x, for example, is equal to, let's say 2 cos squared x minus 1, or it could be 1 minus 2 sine squared x. But of course, which one is best to use in this case, you don't know. Okay, but how about, since we have used this dude, how about we do this one? Now if we isolate 1 here from this one, you will appreciate that 1 is going to be equal to 2 cos squared x minus cos 2x. And I can see that I've already got 2 cos x, and I want something similar. So I can play with that identity and say, okay, 1 is as good as 2 cos squared x minus cos 2x, isn't it? So that's using the identity, but rather in a very strange way, because we are not so used to this way, but yeah, it does work. So let's see what we can do. Of course, this doesn't belong here. We're just using it as our rough work. Now, folks, we have sine x into, now you can see these are like terms. This is like to that. So 2 minus 1 is basically just cos 2x plus 2 cos squared x. Right. So this is what we have, folks. This is what we have. So now what is the best thing to do? Well, we need to play a very long game here. How about we foil it back? Sometimes you have to do a back and forth, okay? It doesn't, in fact, it sounds illegal, but it's not. So cos 2x. Remember, guys, our intention is to try and create some compound angle that we can later contract into that. So this is our mission here. When we multiply here, we get 2 sine x. Now, instead of writing cos squared x, we can just write cos x times cos x using our exponential rules. So we just break it into its factors by removing that square. So look what happens. We get sine x cos 2x plus. This is an identity. It's a sine double angle identity. With multiplication, we can look at this 2. So this is sine. In fact, let's just start with cos, because we can see here we're already doing a sine compound angle identity. So we write the cos x, which is this one that survives. Okay. Then the 2 sine x cos x is going to be just the same as sine 2x. So this is using identities. Now we can see we've got a sine compound angle identity where we've got the first angle and the second angle, and we see these repeat nicely there. So we can see that, okay, this is the same as sine of basically the first angle plus the second angle. This simplifies to sine 3x which is equal to the left hand side. The identity has been proven, but you can see, guys, this is not as direct as you would wish. More work needs to be done. A lot of skilled and strategic, associations need to be aimed for. But again, if you see that we followed the 3-step approach nicely, trying to study every step and see what is best to do. I know that students would not think of issues like this here because you guys almost feel limited because you're not used to splitting numbers whenever that is necessary. Sometimes you add and subtract things that were not there strategically to get to an answer. Sometimes you multiply by 1, which is strategically created. Sometimes you divide by anything that you want, which leads to something that can be used. So maths, guys, is very interesting in that you are not limited to one way of doing things, but whatever you do, you need to stay within the rules. As you can see here, a lot of rules came into play. For example, this is mark worthy. When we factorize, we get a mark, right? But this is already skilled to split the 3 like that. Even to split the 4 sine squared x like that. It's a very skilled way, but perhaps we may not give a mark and say, okay, that's a logical thing. But when we factorize here, that probably becomes a good mark. Again, you see grouping, a skill that is learned in grade 10, right? Right, and of course, when we start using identities, this becomes a very good thing. And an identity here also becomes a good thing, right? Now when we FOIL it out, it's not a big deal at this stage. Okay, the FOIL method, it's like the standard BODMAS approach, so it's not a big deal. But where it matters the most is when we use our identities here to get this answer. Okay, using identities to get to that answer became important, and contracting this using identities again when we contract an expanded identity, that's very, very good. And then of course the final answer, but again we can say 1 2 3 4 5 6, so this one would be worthy of 6 marks instead of 5, depending on how one went about it. But again, it depends on the discretion of the examiners. Because if you decided to do this and it was only worth 5 marks, some marks here may be ignored. Alright guys, so this is just to show that you're not limited to one way of doing things. Yes, it's potentially dangerous because if your mathematical logic is weak, and again your skilled approach here where you use certain things strategically, comfortably, you will not win with that approach. But it's not to say it's not possible to use it, but it demands a bit higher thinking and ability from you. Anyway guys, that's what I wanted to share today. Otherwise, I'll see you some other time. Bye bye.